Are we recording? Yay, now we're recording. Okay, so let's draw magnesium just to get our brains warmed up. Here's my nucleus of my magnesium. How many protons go in there? How do you know? Check the reference table, so let's go ahead and do that. Let me pull one up while we're... Let's see, reference tables, here we go. Okay, find magnesium. It's right here on the left-hand side. Okay, there it is. Okay. Right there. Okay, how many protons go in the nucleus of a magnesium? How many? 12. I love it. So let's pull this back down. Let's write 12 protons here. Okay, we're not going to worry about neutrons right now. We're going to draw the Bohr diagram for this magnesium. How many energy levels? How many rings does it have? Somebody has to help Kyle out here because he wasn't here for a couple days. Okay, how many? 3. How did you know that? 282, and each one of those numbers represents a ring on an energy level on the magnesium. So in the first energy level, how many electrons am I going to put on there? 2. And I'm going to put one on the top and one on the bottom because they're negative and they want to be as far apart from one another as possible. All right, on the second ring, how many do I want to put on there? 8. Okay? Somebody tell Kyle how we put those on there. Good. I love it. You start at the 12 o'clock, then you go to the 3 o'clock, then the 6 o'clock, then the 9 o'clock, and then you do it again. 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, for a total of 8. And then finally, in our last ring, we have how many electrons? 2. Okay, and I'm going to put them 12 o'clock and 3 o'clock. Okay, so that's what the Bohr diagram for magnesium looks like. I don't know if I told you this yesterday, so I'm going to ask this question and I'm going to know in a second. Does anybody know what this outside ring is called? The valence shell. Good, so I did tell you. Valence shell. It's called the valence shell. How many valence electrons does this magnesium have? 2 valence electrons. Okay, so these are valence electrons. And every element in this column on the periodic table, so if I zoom out, okay, this column, which is called a group, they all have 2 valence electrons. See that? 2, 2, 2, 2. The valence electrons are always the electrons that are in the outside shell. Okay, so now here we are. This is kind of where we left off yesterday. And I don't like magnesium as my example to start, so let me just quickly draw fluorine because it's probably a better example. So fluorine has 9 protons. I don't know why I started with magnesium. And then in the first ring, that has 2, and then the second ring, we're going to have how many? How many valence electrons in fluorine while I draw these? 7. Okay, so you can't see anything. I'm just drawing fluorine so that you can get an idea. There's fluorine, and then 1, 2, 3, 4, 5, 6, 7. Okay, so now fluorine is wandering about town, and he's having a grand time, except he has a problem. What's his problem? He's sad. Actually, fluorine is a bully. So fluorine is actually not really that sad because he knows he's really, really, really strong. He's probably the strongest element on the periodic table. And here's his problem. Every element on the periodic table wants a full valence shell. It's called a complete octet. Okay? Right now, fluorine in its valence shell only has 7. But he wants 8. So he's wandering around the universe, and he says, hey, all of my 9 protons are right here, only 2 levels away, or 1 level separating me and this second energy level. And so these 9 protons, which are positively charged, have a really, really strong pull on what's going on outside here in the universe. So if fluorine bumps into another element, it says, hey, I'm taking your electron because I want 8 electrons in my valence shell. That is my goal in life. And so fluorine wanders around, and fluorine finds some poor, unsuspecting soul, and he grabs his electron. I'm doing it in a different color just so that you can know that that electron came from somebody else. And now he has 8 electrons in his valence shell. And he says, I feel so much better. I am now complete. Okay? Here's the problem with this. He has 9 protons. That means he has 9 positives in his nucleus. There's 9, right? I think that's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now he has 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is he neutral anymore? No, he's not neutral anymore. So is he an atom anymore? No. He is now called an ion. And an ion is simply a charged particle. You become an ion by either gaining, like fluorine just did, or losing an electron. Fluorine tends to gain electrons, because think of it this way. He's got $7 in his pocket. 7 valence electrons when he's an atom. He wants 8. There's only one way to get 8, and that is to go out and to get another electron to put into his pocket. So he goes around and he steals an electron from somebody else. When he gets that electron from somebody else, I'm not telling you where that other electron's coming from yet. You'll see in a minute. Once he gets that other electron, now he's got 10 electrons and 9 protons. Now he has a charge. What is his overall charge? Is it positive or is it negative? It is negative. Okay, so backing up just a little itty bitty bit. Do you remember this down here, these numbers? Okay, this was the atomic number, this was the mass number. Well, we got one more number to put in, and that's the number in the upper right corner. And that is going to be the charge. I'm just going to redraw it on another piece of paper so you can see it bigger. Okay, so here's the atomic number, here's the mass number, and here is the net charge of that particle. Now I'm calling it a particle, not an atom anymore, because an atom is neutral, and that's why I was kind of drilling that home. An atom is neutral. If there is nothing written in the upper right-hand corner, let's say I draw fluorine like this, and there is no number up here in the upper right-hand corner, then we assume that it is an atom with no charge. And sometimes, very, very rarely, you'll see a 0. Okay? That just means no charge. But if there's nothing written there, we assume it's a 0. Okay? Fluorine gets a 9 down here because that's its atomic number. It gets a 19 up here because that's its mass number of its most abundant isotope. Okay? So far, so good? All right, so that's fluorine. Fluorine is a bully. Fluorine likes to take electrons away from others. If you meet fluorine in a cold, dark alley, you're getting your tushy kicked. He's taking your electron. There is no other way. Okay, fluorine is that guy. Now let's take a look at sodium. Sodium has 11 protons in its nucleus. If you don't believe me, take a glance down at your periodic table. It's on the left-hand side. It's in the first group, group 1. See it there?
Yeah.
Okay, so now we've got how many rings or how many energy levels does sodium need to have? 3. Okay, so I think I got 3 on there. They're not perfectly neat, but I got 3. In the first energy level, I have 2 electrons. In the second energy level, I have 8 electrons. And in the third energy level, I have 1 electron. Capiche so far?
Yeah.
Okay. Now, what is every atom's goal? To have how many electrons in their valence shell? 8. It's called a complete octet. Octet meaning 8. All right, so now let's look at sodium, and you tell me what you think is going to happen here. Sodium has 1 electron in its valence shell. He's wandering around in the universe. Lexi? Got it? You understand what I'm saying? Okay. He's wandering around. How is he going to get 8? Is he going to be able to go up to a friend and say, hey, give me 7 electrons to make 8? No. So what is he going to do? Yep, he's going to lose his valence electron. And when he loses that valence electron, this whole ring goes away. Okay? So now instead of having 11 protons, which are positive, I'll draw the positives over here. There's 5, 6, 7, 8, 9, 10, 11. And 11 negatives. I'm losing track of how many I wrote there. Now he lost this electron. So what is his overall net charge? Positive. So this is an atom. I have nothing written in the upper right-hand corner. If I see sodium with a +1 in the upper right-hand corner, it is no longer an atom. It is called an ion. And why is it a +1 charge? Because it lost an electron. Okay, so that's the overall scoop. Now let's write it all down so that you have it in your notes. Okay, an ion is a charged particle and it occurs when you gain or lose electrons. That's when you make an ion. When you gain an electron, you become a negative ion. When you lose an electron, you become a positive ion. So ions are charged particles. They become charged by either the gaining or the losing of electrons. And if you gain an electron, you become negative. If you lose an electron, you become positive. Okay, everybody good with that so far? Let's look at the periodic table. Here it is. Isn't it cute? Oh, it's adorable, right? If you look at the elements on the periodic table, let's forget about this section in the middle from 3 through 12. Look at these 2 columns and look in the upper right-hand corners. Okay? First of all the elements in this column have 1 valence electron. Do you see how they all have +1s here? What do all of those elements do in order to complete the octet? They lose how many? 1. Look at the second column. They all have how many valence electrons? 2. And what do all of those guys do in order to get a stable valence shell, 8 in their valence shell? They're going to lose 2. Okay? The only one that's kind of a little bit different is beryllium. When it loses 2, it only has 2 in its valence shell. And do you want to know why that is, or can you tell me why that is? If you think about beryllium, and it looks like this. Here's beryllium. I'm going to start drawing them like this because it's just easier. Be, you know how many protons are in there. There's 4 in there. Okay, and here's my 2 rings. Okay, so if I have 2 electrons in this first ring, I'm just drawing them black because, and 2 electrons in my second ring, and I lose those 2 electrons, is this ring full? Why? It's the first ring, and how many electrons can the first ring hold? It can only hold 2. So beryllium's kind of a little bit different in that it doesn't want 8. It'll be perfectly happy with the 2 because it's still a full shell on the outset. Okay. But all the others, they lose that too. Now skip this section in here because these are the transition metals. Fluorine, chlorine, bromine, iodine, acetine, right here. Okay? Fluorine has a -1. You now know why it has a -1. It has a -1 because it gains an electron. Fluorine's the bully. It goes out. It's taking what it wants. It's going to take an electron. Chlorine, you see how many they have? Okay, chlorine, most of the time, will become a -1. From now until probably January or February, it'll be a -1 for you. Okay? The top number is the most common that happens. In this case, it's a -1. Bromine, the same thing. Iodine, the same thing. They all want to gain 1 electron from somewhere. And they're going to gain them from an element that wants to lose them. In this case, these guys. They want to lose them. Those guys want to gain them. So the losers live over here. The gainers, or the winners, are over there. Now, look at column 18. You might want to look on yours. Okay? I want you to look at helium, neon, and argon. You see how they have a little 0 in the upper right-hand corner? Why do you think that is? They already have 8. So do they want to gain or lose anything? No. Those elements in group 18 are very stable, meaning they're not going to react with anything because they have 8. They're not on the hunt. They're not going out. They're not looking for anything. When you get to krypton, up until about 10-15 years ago, it only had the 0 there. But now there's a +2. And that +2 happens because krypton, on rare occasions, will encounter fluorine, and fluorine is strong enough to pull an electron away from krypton. Okay? Doesn't happen often, but it does happen. And the reason why helium, neon, and argon, let's look at them. Here's helium, here's neon, here's argon. Okay? Helium has 2 electrons in its first shell. You can't see what I'm drawing. Helium has 2 electrons in its first shell. Just imagine this is a circle. I'm just drawing it as 1. Neon has a 2 and then an 8. Argon has a 2 and an 8 and an 8. When you get to krypton, you have a 2, 8, 18, 8. You see how far away these are from that nucleus? This is my nucleus right here. That's an eraser. Come back here. That's my nucleus. And that's where the positives are living. The positive protons are in there. These positive protons are holding all of these negative electrons onto the atom. You see how far this 8 is getting away from there? This is losing its power. So these electrons can actually be removed, but only by a really, really strong element, which we now know is fluorine. Okay, so krypton can react with fluorine. It's rare. See how xenon is actually even reacting a little bit more? It's got a couple more ways that it can lose electrons with fluorine. Okay, radon has a 0 only because they haven't seen it do anything yet. Not that it can't. It just hasn't reacted with anything yet. Okay? So, bottom line, If you see an element, for instance, I'll do fluorine again, and there is nothing in the upper right-hand corner, then it is an atom. If you see fluorine with a -1, sometimes they'll write it 1 negative. It's the same thing. If you see anything with a charge in the upper right-hand corner, now you need to know you have changed the number of electrons. I usually write my sign first, +2. How many protons in calcium? 20. Okay. How many electrons in that calcium? How many? 18. Excelente. Okay. Why 18? It became positive, which means it lost electrons. What about oxygen -2? How many protons does it have? How many electrons does it have? I'm leaving neutrons out right now because I didn't give you a mass. Allison, how many protons for oxygen? Say it louder. 8. I love it. So if it has 8 protons and has a charge of -2, how many electrons does it have? 10 electrons. There's your ions, my friends. Okay? All right, last thing I'm going to tell you today. Let's just go back to that sheet where I was actually writing stuff down. If you are a negative ion, you have a special name. You are called an anion. A negative ion. A negative ion. Anion. If you are a positive ion, you are called a cation. Okay? Ready for a bad chemistry joke? Cats have paws. They are positive. Come on, roll your eyes. It's a bad chemistry joke. So now, I will show you the cutest little, if I can get to it. Go away, go away, go away. Cations are positive. That's one way to remember it. They have little paws. This one's cute too. Cations are positively charged. Okay? That's another way to remember it. The other way to remember, come on, those are bad chemistry jokes. You gotta laugh just a little bit. Okay, haha. The other way that you can remember this is if you look at the word cation, and I'm gonna take the T, I'm gonna make it black. There's a positive sign right in the middle of the word. Okay, that's another way to remember that cations are positive. All right, any questions on ions? Now we can practice some. Let me shut the video off. Element, carbon. Can we zoom in here? What's its atomic number? 6. Excelente. Which means it has how many protons? 6. Okay? It is an atom. Okay? So how many electrons is it going to have? 6. How did I know it was an atom? They didn't say it was an ion over here. What group number is it in? Okay, so when you're looking at your periodic table, let me see if I can find my periodic table again. Where'd it go? There it is. Yeah, it should be group 14. The group numbers are up on top, so it's right here, group 14. I just want to show you. So for those of you who are not with us, is there anybody out today? No, I don't think so. Okay, group 14, right here, there's carbon. So group 14, how many valence electrons does it have? How many? 4. Beautiful. Okay, this is cation or anion. When we look at carbon on here, it has 3 ions that it can form. It can form both a cation, which are the positive ions, and a negative anion. It can form both cations or anions. So let's write both there. It can form both cations and anions. It's kind of confused. It has 4 valence electrons. It doesn't know whether it should lose them or it should gain some more. So it could go either way. What's the most common thing that it does? It forms a -4, which means it's going to gain 4 electrons. All right, oxygen. Atomic number is 8. 8 protons, 8 electrons. What group? Group 16. How many valence electrons does it have? How many? 6. And it's going to form what? An anion or a cation? Anion. Okay, it's going to form a -2 charge. Okay, potassium. 19. That means it has 19 protons, 19 electrons. It's in group number 1. How many valence electrons does it have? 1. And does it form a cation or an anion? Which one? Cation. Good. Arsenic. That's As. So let's find it on our periodic table. It's right here. Okay. How many protons does it have? 33. That means it's going to have 33 electrons. It's in group number 15. It has 5 valence electrons, and it forms both cations and anions. Okay. Iodine. Am I going too fast, or are you okay? Yeah. All right. Iodine's right here. 53. 53 protons, 53 electrons. It's in group 17. It has how many valence electrons? 7. And it can form both. However, most of the time it's going to be a -1. That's why it's listed up on top. The one that happens the most is up on top. So it's a -1. All right, calcium. Calcium's right here. Its atomic number is 20. 20 protons, 20 electrons. It's in group number 2. It has 2 valence electrons, and it forms a cation. Getting the hang of these? Okay, boron. There's boron right here. 5 protons, 5 atomic number, 5 electrons, group number 13. How many valence electrons? 3. Cation, anion, or both? Yep, cation. Good. And finally we have neon. So neon is over here. Okay. Neon is number 10. It's in group 18. How many valence electrons does neon have? 8. And it doesn't form either a cation or an anion. It's neither a cation or an anion. All right, in the first table, for each of the ions, indicate the total number of protons and electrons. In the second table, when given the protons and electrons, indicate the ion with the correct charge. All right, now we're getting some good stuff here. All right, you've got chlorine. How many protons does it have? 17. If it has a -1 charge, how many electrons does it have? 18. Good. All right, potassium. Atomic number or number of protons is going to be 19. It has a +1 charge, so how many electrons does it have? 18. Sulfur. 16. Good. -2 charge, so how many electrons does it have? 18. Strontium. I don't know. I need a periodic table for that one. Okay. Yeah, it's over here somewhere. There it is. 38. Good. So 38 protons with a +2 charge means it's going to have 36 electrons. Aluminum is 13, but it has a +3 charge, so how many electrons does it have? 10. It's going to have more positives than negatives. Phosphorus with a -3 charge. Phosphorus is over here. It usually has 15 protons, but it has a -3 charge, so it's going to have how many? Where's my... There it is. 18. Good. And then silicon with a -4. So silicon is over here. Okay. It usually has 14, but with a -4 charge, it's going to have how many? 18. Beautiful. Okay. Now we have to write the ion on the other chart. Okay. Keep losing my cursor. All right. If you have 56 protons, what element are you? Ba. Okay. You have 54 electrons, so what's your overall charge? +2. Good. 87 protons. Where is 87? Oh, here it is. Francium, right? And you have 86 electrons. What's your charge? Jacob, do you know? What is it? +1. You are on the ball. Good job. All right, 84 protons. 84 is PO. But 86 electrons, so my charge is negative what? 2. Okay. 50 protons. It's going to be 10. Okay. I have 46 electrons, so it's going to be 10 with a +4. Good. 32 protons is GE. You have 36 electrons, so your charge is -4. 55 protons, CS. But you have 54 electrons, so your charge is plus... How many? Good. We got one more to go here, guys. Hang in there. 12 is magnesium. What's its charge? +2. Okay. Finish the other side tonight. Okay? We'll work on that in the morning.